This is lab 3, and in this lab we went over circuits. We went over circuits in the FET simulation. Our first simulation was doing batteries in series. The way the batteries in series works is that their voltages get added, so the total voltage of the two batteries combined would be about 3. As you see down here, with the ammeter removed, the voltmeter read 3 volts, which makes sense because the difference between the two batteries is the negative side and positive side of the two batteries is 3 volts. It would make sense that the entire circuit remains the same. The predicted current was 0.0204 amps. The measured current is 0.02 amps. Obviously, it's because it just goes to the hundredths place that it didn't go any further. But basically, those are about the same number. When placed backwards, the amp meters will read a negative value as it is going against the readings. And when ammeter 2 is removed, it disconnects the current flow between the two wires. So when ammeter is removed, ammeter 1, which is up here, would read 0 because there's no current flowing. It has the electrons have nowhere to go, but the voltage difference is 3. Even more of the series, this is the current. As I said, it was 0.02. The sum of V when you go around the circuit will always be 0, especially in an ideal circuit. Basically, from this point here at the top, from here to there, to there, to there, to there, to there, will equal 0. The graph is right here. As you go to A to B, it goes 3, and as you go through the resistors, it takes away from the voltage potential until it reaches 0 again once you hit F, which was, I think, about right here after the second resistor, and then just goes straight back into the battery. When you put the meter parallel, it acts kind of like another wire, so and electricity always goes in the path of least resistance, so it'll go through the first resistor. It'll have no need to go through this resisting 100 ohm resistor, and it'll go through the resisting free ammeter right there, leading to a higher current of 0.06. Based on the lighter value of the rounded value of 0.02 amps, the resistance of 47 resistor is 48 ohms, in the 100 resistor would be 102. Obviously, if you use the 0.0204 number, it would probably get you the actual number. The wires and ammeter basically have no resistance at all. Actually, in the simulation, they do have no resistance. Going to RC circuits or resistor capacitor circuits, the way it was observed was that when it was hooked together, the light would work initially, but as the capacitor was getting charged up, it was causing a resistance, causing the light to dim until it was completely off, and the voltage contained in the capacitor was equal to the voltage contained in the battery, so basically no flow of charges can move. When the battery's disconnected and you connect a wire between the two, the capacitor runs backwards compared to the battery. It was about a 1.6 second both ways from charge to discharge for the 10 ohm light, and about 3 seconds for the 20 ohm light. The resistor, it's like the time constant found by the slope was 0.166. And to find the actual time it would take, it's 1 divided by the RC, which is about 6 seconds. The predicted RC, which is 30, which is the resistance, times 0.2, which is the capacitor number, equals 6. These what ifs, if in real life you use an actual ammeter instead of a simulated one, what's the difference in real ammeter, how would it affect? It basically would have resistance, causing the voltage in that area to slightly decrease from the beginning to the end, and then overall it would cause the current to drop a little bit throughout the entire circuit. Um, if this experiment was in real life, no resistor in the circuit, how quickly would the ideal model predicted capacitor reach full charge? Well, if there's no resistance, the RC value would be 0. So 1 divided by RC would be infinity, basically saying this will happen instantly, basically. This won't happen in real life because there's always going to be some type of resistance, no matter how small. And so that would be how that